Bom ne Sarah's coming. Sarah's one is such grandparents. Guys, Sarah's one is such grandparents.
Registrar diyorsun odur tek.
Ha?
Registrar.
Não se tem such grandparents. Such paga. Não é que dois graus no bom. E dois anos estamos no museu assim. E assim que Sarah's. Onde se quer dar grandparents? É mesmo um legal. Sarah's one is such grandparents.
Registrar diyorsun odur tek. Registrar.
Noon mag-cancel. बस
يلا vai ser bom. Acho que se
क्योंकि जब यहाँ पर वो होता है क्या नहीं नहीं इसका मुझे अच्छे से समझ ही नहीं हमें
बुलाएंगे आ जाएंगे दीवार से मुश्किल है इस बच्चे
agar wayne da wani ya iska ne shi
Salta हमने शुरू किया जाकर
Assalamu alaikum, Professor Mushtaq Darji Saab. Can you hear me?
I think there is some in a position to hear anything.
Am I not clearly audible to you, sir?
Assalamu
alaikum, sir.
Wait.
Yeah, it was just now. Just now it started.
Yeah,
Assalamu alaikum,
Professor
Dr. Saab.
Darji Saab has also joined us. Assalamu alaikum, sir.
Wa
Salam
alaikum.
alaikum. Wa alaikum salam.
Thank you, sir. Thank you for joining. I think a good number of participants have already joined us. There is issue from Pulwama side. The internet is not working well. Some of the participants were calling me, and we can with the introduction and other things. By 11, we'll be able to start your presentation, sir. So I think let us start. Mushtaq Saab, Professor Mushtaq Saab, should we start?
Yeah, of course, sir.
It will take
Zafar
another
Saab, Assalamualaikum.
few minutes to.
Assalamualaikum, walaikum salam.
Sir, so nice of you, sir. So nice of you.
Pleasure is always ours, sir.
Well, I extend a very good morning to all the participants as well as today's lead speaker, Professor Zafar Ahmad Rishi Saab, and also to our in charge director, Professor Mushtaq Ahmad Darji Saab. Our today's moderator is going to be Dr. Sabira Muzaffar from the Department of Food Sciences. We are, highly delighted and highly honored and privileged to have with us one of the acclaimed academicians and accomplished researchers, Professor Zafar Ahmad Rishi Saab, professor in the Department of Botany of the University of Kashmir, who has earlier served as Registrar, University of Kashmir, Dean of Research, University of Kashmir, as well as Honorary Director of the Center for Taxonomy at the University of Kashmir. And, Professor Zafar Rishi Saab is an authority in invasive ecology, invasive biology, ecology, and biodiversity areas. So today we are going to cut some ice on issues related to ecology and ecological research. In the morning, the lecture will be delivered by Professor Zafar Ahmad Rishi Saab on COVID-19, whether COVID-19 will be the last pandemic or not, or whether there are many more such pandemics in the offing. And in the afternoon session, we'll be having a lecture by Dr. Manzoor Ahmad Shah Saab from the Department of Botany on ecological research in Himalayan perspective. So I would, straight away first invite and request Professor Mushtaq Ahmad Darji Saab to welcome our guest, our lead speaker. Then our moderator of the day, Dr. Sabira Muzaffar, will introduce the resource person. Professor Mushtaq Ahmad Darji Saab, over to you, please.
Yeah, Assalamualaikum to all the participants and especially to our Zafar Saab, who is the lead speaker this time with us. A very good morning to all because some people are from outside. Sir, it is a very privilege for us to have with us Dr. Zafar Saab, who is a renowned researcher, having done so many of the projects which are sponsored by different institutions and has more than 120 publications. And now he is now having an authority over the current issues as well. So today now he is going to speak on COVID-19, and I also welcome all participants to this program. Okay, sir, please go ahead, sir.
Yes, thank you very much, Professor Mushtaq Ahmad Darji Saab, for those opening remarks. Now I would straight hand over the session to our moderator of the session, moderator of this particular session, Dr. Sabira Muzaffar from the Department of Science. Dr. Sabira, you are requested to kindly introduce our speaker, our resource person, Professor Zafar Saab. Please go ahead.
Thank you so much, sir. Am I audible?
Yeah, you are.
Thank you, sir. On
Dr.
behalf of the
Sabira Muzaffar, can you hear me?
Yes, sir. Okay, sir. On behalf of the participants and the UGC HRDC Srinagar, I welcome
Dr.
Professor.
Sabira has joined us. I can see her in the session. Just a minute. Yes, Dr. Sabira has joined us. Probably she's having some issue. Please unmute yourself. Dr. Sabira, please unmute yourself.
He is speaking.
Okay. I'm not able to hear her.
Am I audible, sir?
Yes, you are audible. Please go ahead.
Okay. On behalf of the participants and the UGC HRDC Srinagar, I welcome Professor Zafar Ahmad Rishi, sir, to this 2-week refresher course in science. Professor Rishi needs no introduction. He is one of the prominent researchers of the university, having about 30 years of experience in teaching and 35 years in research. Professor Rishi has held key positions of registrar and dean research of the university. Besides being head of the Department of Botany, he has been the honorary director of Center of Plant Taxonomy also in year 2012. Professor Rishi's major research focus has been invasion biology and ecology and biodiversity. Sir has successfully completed almost 11 research projects and many are underway, which are mostly related to grassland ecology, mycorrhizal diversity, species recovery, and restoration. Am I audible now, sir?
Yeah,
Yes,
carry on.
Professor Rishi has supervised about 46 students and has collaborated with several international projects also, like Indo-US project, Indo-German, and Indo-French projects. Sir is a well-known researcher, having published about 136 research papers in well-reputed journals. Further, he has authored one book and almost 24 book chapters. Sir has an overwhelming H index of 26 and citations of more than 2,000. Professor Rishi is a fellow of National Institute of Ecology, New Delhi. He has also been nominated as a member on the Technical Expert Committee on Forest Biotechnology by Department of Biotechnology, Ministry of Science and Technology, Government of India. He has also been appointed as assessor by National Assessment and Accreditation Council, Bengaluru. Sir has also been appointed as functional area expert by the National Accreditation Board for Education and Training Quality Control of India. He has also been honored with the Best Teacher Award by Directorate by DICA, University of Kashmir during 2007-2008. With this brief introduction, I want to invite Professor Zafar Ahmed Rishi, sir, for delivering this much-awaited lecture on COVID-19 will not be the last pandemic. Over to you, sir.
Okay. Assalamu alaikum and good morning, everybody. Am I audible?
yes, sir, you're audible.
Is my presentation also, I mean...
Yes, you need to put the slideshow on, sir.
Yes, slideshow is on.
Yes, it's on, sir.
It's on?
Yes, sir, please go ahead.
Okay. Colleagues, I always consider it an opportunity to speak to you in this staff academic college. Whenever they have invited me, I have always said yes, I would basically be participating in this. Reason being that I always consider that the participants is a very challenging, say, gathering, and then one has to prepare a lot for it. And then one has to be very respectful to his colleagues. And then in the process, whether I say communicate anything new to you, that is something different, that needs to be, say, that is questionable. But at least I learn a lot while preparing for the lectures which I deliver in the staff academic college. I must thank profusely Professor Mushtaq Saab for inviting me, and also Dr. Geer Saab for inviting and then following it up also. I am very grateful to him that he remains always in touch, tells you that this is the link that you shall have to actually join at this time. I mean, that is something very professional of Dr. Geer. It's very heartening to see that there are very large number of, say, the participants participating in this refresher course. Anyway, there would be many people speaking on COVID. I would basically not be having a sort of a scientific lecture about this COVID. I would be having a sort of a layman type of a assessment of this COVID, that what it is, how it is happening, whether it would happen, whether such type of a pandemic would happen again or not. That basically, I mean, somehow what basically I thought was coming to my mind when I was passing through this COVID-19 pandemic. Those are the questions that I will try basically to address. These are very, very layman type of questions, not very scientific questions as to what it is, genome, where are the mutations happening, nothing of that sort. Presumably there would be other qualified speakers who speak on that. Now, the prologue, the introduction of my lecture is a quote from one of the famous scientists, Joshua Lederberg, who got a Nobel Prize. Right, and he said that the single biggest threat to man's continued dominance on the planet is the virus. Now, in our lifetime, presumably, we did not appreciate this statement of Joshua Lederberg, but now I am appreciating what he had said so many years before. Would you put your mics basically, I mean, off, because there is some background noise as well. Anyway, now Joshua Lederberg, a Nobel laureate, said so long, right, that the single biggest threat to man's continued dominance on the planet is virus. And this basically became apparent when the COVID-19 struck us. I mean, all of us are of the same, almost age group. Most of you would be, say, younger to us. I had never seen such type of a pandemic. And then our never appreciated the importance of viruses the way that we now appreciate the importance of viruses, right? And then we have influenza, we have coronavirus, we have Ebola, we have hepatitis. We have seen basically HIV, but we have not been affected basically by these viruses the way the COVID-19 affected us. And then somehow this statement of Joshua Lederberg comes out to be true. Now, as you all know, that in the background, this is the market of Wuhan market in China, wherein in December, in 19 December, in 2019, there were certain cases reported, wherein doctors were of this opinion that is a very different type of a pneumonia. These are not people are not presenting with the usual symptoms, and as such, by 31st of December, the China Health Authority alerted the World Health Organization about something very new, type of pneumonia occurring in patients who were presenting themselves in the hospitals, right? Background, the market you will keep in mind because we will be having some discussion about this, the activities that are happening in this market and how they are linked to the spread of COVID-19. Anyway, Chinese somehow in December 2019 alerted WHO that there is something unusual happening in our place. Then you know that there were news reports, this, that, so on and so forth. And ultimately, on 11th of March 2020, the coronavirus was declared as world pandemic, right, by the Director General of WHO. And then all of a sudden, all of us started talking about they have started basically, all of us have started talking about this virus. And then it started, say, hitting us also in different ways. And then we felt very concerned as to what was happening around us. Now, this was a virus which swept all across the globe. You could see here is the picture of the virus, wherein you have all the flags of different countries. The emphasis is that it was a virus which didn't occur, ultimately did not remain restricted to China. It spread everywhere, right? Anyway, and then till July 2020, 18 to 16 trillion US dollar loss has been estimated, and it is counting. You do not know how long this global economic recession would continue. And then the pictures that you see here, that this is basically a huge rush of people migrating from different places to their hometowns. This one shows that most of the people were searching for the topics related to COVID in US. Then this lady is carrying 2 children to her home. This was basically, these were the usual pictures that were beaming in our television, on our television sets. People say somehow managing to get into a lorry to go back home. Anyway, it influenced every walk of life, be it education, be it our social life, be it our stress levels, be it economy, be it health, be it physical, mental, or emotional health. Everything got influenced by this COVID pandemic, right? Now, and then they say that this pandemic brought into, critical focus the concept of globalization. We would talk, say, warmly about this globalization. They said that goodbye globalization and welcome globalization. There is, economic slowdown. This economic slowdown has translated into job losses. It has resulted into many kinds of, say, social strife. Even in families, there have been some sort of actually troubles. Students are not getting in-house, in-person teaching, and so on and so forth. Whether it is teaching, whether it is research, whether it is economic activity, anything you count, you will find that there is some a slowness of the process happening. And then it is very difficult to pick up. Still, we are not able to pick up the threads, right? And somehow we are finding that there is this process of globalization happening around. Now, one thing is very sure, that this pandemic is not something very new. It's not a fact that we have been struck by the coronavirus, a pandemic for the first time. No. Instead, all through the human history, we have seen pandemics. We have seen pandemics about 5,000 years back. And then this happened also incidentally in a prehistoric Chinese village. And then all the people who were basically living there, they were killed, they were burned down. Likewise, you had plague of Athens in 430 BC, right? And then likewise, you have Antonian plague, right? Soldiers return to the Roman Empire when they returned after their victories. They got smallpox-like symptoms. I mean, people say that it could have been smallpox. Anyway, then there is something which is called as Black Death. And then if you talk about the pandemics and then you don't talk about Black Death, it's almost incomplete. Black Death was caused by a bacterium, Yersinia pestis. I mean, and they say that half of the Europe's population was wiped out because of this Black Death. And then you had smallpox, then you had plagues, then you had yellow fever, then you have HIV/AIDS, you have Spanish flu, Russian flu, Asian flu, then you have SARS, then you have MERS, then you have Ebola, then you have swine flu, and then you have novel coronavirus. I mean, issue is this, that earlier also you had pandemics. Now you are also having a pandemic. There are certain striking differences between the earlier pandemics, and there are striking similarities also between the earlier and the pandemic that we have now. Now, the difference is that earlier the level of globalization that we have today was not there, and as such the impact of the plagues was very limited because they were the causative organism was not carried beyond certain limits, right? Spatial limits. Nowadays you are live in a sort of a global village. You would talk fondly about this global village. All of a sudden now you are somehow re-examining this global village concept because of the connections with economic, movement of people, travel, pilgrimage, cultural, religious tourism, so on and so forth. And then all of a sudden we find that all these have their own the impacts as well. They have been drivers of this coronavirus pandemic. Anyway, now these are the details. 5 million people have died because of the plague, which and then place of origin of this was China. Then Japanese smallpox, 1 million people died. Korea was the place of origin. The plague of Justinian, you are not sure that where from it originated, but it was a bacteria that caused it. Black Death it originated in Asia, 200 million people killed. Then Great Plague of London, 1 lakh people died. It also originated in China. Then cholera pandemics, they have originated in India. Then there are many basically say these pandemics, and then they have caused lot many deaths. And then now you have this COVID-19, right, which has so far till today, 1.84 million people have died, and people suspect that it originated in Wuhan, China. Right. Now, this is something, basically, this is the work which was published in Nature, right, in 2008 by Jones, wherein they are basically something presenting which is very important for us to learn. One, that look at this from 1940 to 2000, you will find that the number of the emerging infectious diseases is increasing. Now, emerging infectious diseases would include diseases that cause pandemics as well. Now, if you look basically at the data at the bars from 1940 to 2000, you will find that there is an increase. Now, that means what I am trying basically to say, convey to you is that there is something basically happening, which is triggering, say, the increase in the number of AID events. And then you have these AID events, these emerging infectious diseases caused by helminths, by fungi, by protozoa, viruses. Look at viruses, white bacteria, right? Lesser number by bacteria, more by helminths, and then fungi. Now look at these. Most of them have been zoonotic. That means zoonotic are those say, emerging infectious diseases which move between, say, animals and to human beings, right? Now, of these, 72% originated in wildlife. Now, this virus, this COVID-19 is also a zoonotic virus. People suspect that it moved from animals, right, to the human beings. There was a sort of a spillover. Now look at this, in 1940 to 2000, you are always finding that zoonotic, basically, although the organism, the animal is not specified, is also increasing. That means more you get in contact with wild animals, more you trade basically in wild animals, more are the possibilities of transfer of, say, infectious diseases from these animals into human beings. And if you say, recollect that I had told you to basically keep that bag market Wuhan into background, the market was full of basically the items of related to these animals. It was basically, I mean, they are selling different kinds of, say, these zoonotic animals, and then it is expected that from one or the other of those, say, those animals, this virus, this COVID-19 virus moved into the human beings, and then ultimately it's spread, right? Now, what I'm saying is that that infectious diseases are in a rise, and then out of those infectious diseases, the diseases which are caused basically as a result of, say, movement of these causative organisms into, say, humans from animals is also increasing, right? That means animals somehow, or interaction of, or increased interaction of human beings with wild animals or domesticated animals is one of the major causes of spread of or increase in the incidence of infectious disease, right? Now, Woolhouse, this was also published in Nature. Now you will find that just a minute, right? Now, between 1940 and 2004, they collected data, and they found that 335 emerging disease events were reported, right? They said that from 1940 to 2004, 335, say, emerging disease events were reported. Out of those, 182 were caused by bacteria, 11 by helminths, different organisms, and then 85 were also caused by viruses, right? Now that means you have different types of, say, organisms having capability of causing disease to human beings, right? And then the diseases are going global. There are reasons basically for the disease to go global, about which we will be having some amount of discussion. And the COVID-19 was caused by a virus. I am trying to emphasize that it's not the viruses alone which can cause these emerging diseases. You can have a bacterial infection tomorrow, you can have a fungal infection, you can have protozoa moving from, say, animals or from some other organism into human beings, right? Now look at this. Most of these out of these 335 emerging disease events, most of them occurred in USA. Now the USA and China are trading charges that the COVID or somehow took birth in China. But out of these 335 which were mentioned basically by this Woolhouse in Nature paper, you have most of them happening in USA. That means USA is one such country where you have most of the events of these emerging infectious diseases happening. We have least of them in Mexico, many of them in UK, Australia, even in India, you have some of them happening. Now that means there is something, if you look at US, if you look at its basically, say, behavior, if you look at its economy, if you look at its basically, say, social milieu, you would basically be able to draw certain conclusions as to what could be promoting, say, these infectious, disease events in USA. And actually one way of, say, protecting ourselves is not to follow USA, right, in every manner, right? And then in the process get infected by these viruses, right? Now, this is Harvard Global Health Institute data, which also suggests that there is basically an upward trend in the number of basically, the number of countries which are experiencing the events of these experiencing significant disease outbreaks is also increasing. Now, zoonotic diseases are on a rise. You will find that, look at from 1900 to 2020 data. This was a sort of an extrapolation from here onwards because paper was published in 2008 only. Look at this. You had to begin with very less basically zoonotic disease occurring. Now you have a lot of them. Now, if you move basically extrapolate it further, you should be expecting that we are going to face many such episodes of these pandemics, right? And then we shall have to actually take measures by which we will be able to somehow restrict the spread of these viruses or these causative organisms of the emerging infectious disease. Now, most of them, as I said, now 60% of all infectious basically diseases, right, in humans basically are caused by the zoonosis. Zoonosis means that transmission from, say, animals to humans. And 70% of all emerging, say, infectious diseases are zoonotic. That means if you take care of these animals, like you have, say, chimpanzees, you have, say, bats, largely you have then fowl, then you have birds, then you have camel, then you have chimpanzees, then you have gorillas. I mean, if you are able to avoid the contact with the animals, there is every likelihood that you may basically be able to control the pandemic. But the things that are happening around us, but the activities that we are undertaking is increasing the contact of human beings with the animals, and consequently you are expecting, I mean, look at the culture in Kashmir also. Now you have culture of pets, right? You are getting, I mean, photographed with pets instead of, say, human beings. Now you have, say, cats, right? Anyway, many things now sleeping with the human beings as well. And consequently, as you are going to experience many of these transmission of disease, right? And then naturally, this is one take-home message, that we should be very careful. We should be very careful about these pets, right? And then having more contact with them. Look at the influenza virus and look at the primary, I mean, birds, animals, right? Bovine tuberculosis animals, Ebola, look at them. MERS, again camel. Nipah, again animal. Then SARS, again animal. I mean, most of the very well-known, say, pandemics have been caused basically by spillover from animals to human beings of the virus, right? And then this is the example. I mean, this is a bat on one side, and this is basically a pangolin on our other side. This pangolin is suspected to be one of the intermediate hosts of COVID-19 virus, right? Although there are discussions about it, whether it came from birds or whether it came from pangolins, but by and large, the consensus is that pangolin is suspected to be the intermediate host of COVID-19 virus. And then which means that virus was thriving in this pangolin. And then since you were dealing with trading basically with in this animal products in the Wuhan market, you increased the possibility of transmission of this virus from this pangolin into the human beings. And then once it was in human beings, then it basically moved. It was a small event, then it basically became a larger event, then it started moving from, say one human being to another human being, and then this is how it happened, right? Now, you should understand that pandemics emerge from the microbial diversity. You have huge diversity of microbes, right? And 70% of emerging diseases, right? And almost all pandemics are zoonosis and are caused by the microbes, right? And these 1.7 million viruses are currently undiscovered. It is an estimate that people suspect that there are 1.7 million viruses which are thought to be existing in mammals and avian hosts, right? And out of these, right, look at 631,000, 827,000 could basically have the ability to infect humans. One, that you are increasing the contact with the basically animals. Second, many of the viruses are unknown. Many of these unknown viruses have the potential to affect human beings. And as such, there is every likelihood in future also you are going to actually face a pandemic situation like the one that we faced basically as a consequence of the spread of this COVID-19, right? Now, most important reservoirs of pathogens, right, with pandemic potential are mammals. Now, what we are doing is we are saying that amongst organisms, I mean, the which cause diseases, the microbes should be focused upon, right? Then amongst the microbes, viruses should receive more focus. Then amongst the animals, the mammals basically and birds should be receiving more attention. Why? Because mammals are or serve as the most important reservoir of pathogens. Likewise, birds, including water birds. Then livestock, pigs, camels, and poultry. Mammals such as bats, rodents, primates, birds, water birds, livestock like pigs, camels, and poultry. These should receive a lot of attention from us together with, say, bacteria and viruses, if we have basically to somehow, say, predict as to what is going to happen in future, or we have the capacity to, say, prevent further, say, such type of these pandemics from happening. They say the estimate is that on average, one new infectious disease emerges in humans every 4 months. In every 4 months, right, the data suggests that one new infectious disease emerges, right? And 75% of these infections come from animals. Now, if you are increasing your contact because of whatever reason with the animals, right, you have every likelihood to contract basically a disease. And because of the globalization, movement of people, movement of products, right, trade, travel, right, tourism, you are intertwined world, you are going to basically give birth to another, say, the pandemic, right? The conditions around us are very suitable for pandemics to happen, right? That is what basically I want to emphasize. And these zoonotic diseases can very easily spill over to humans, right? And then I mean, spread to other parts of the world. And then you have unequal world. Some have the potential basically to treat their patients, others do not have. That inequality came to fore when this COVID-19 struck us, right? Now, India also has witnessed many kinds of these emerging infectious diseases. You have had Shimla plague, likewise you had diphtheria in Delhi, you had chikungunya, right, in South India, then you had cholera also in Chennai. Likewise, you had plague in Uttarakhand, so on and so forth. I mean, point that I want to make is that it is not a fact that we would argue that it is the disease of the first world, it is the disease of, say, most advanced economies. We would basically sit a cozy, we are not basically going to be impacted. That is not a fact. India also has its own set of problems, right? And then in case a pandemic strikes a poor country, I mean, with limited the health infrastructure, the consequences we have already seen. And actually, we also need to basically gear up, pull our socks in order to see to it that we at least do not basically give birth to the new kind of a disease, which from here would spread to other parts of the world. Now, this is a heat map, right? And this is something very interesting. This was this comes from a paper which was published in Nature Communications, right? Now, the first one is something which is predicted distribution of events, right? Anyway, I mean, you can find that this is North America, this is somewhere here, Europe. Look at this graph, the B one, lower one, and look at the India, right? Anyway, now you are, I mean, this is basically B shows the estimated risk of event locations. Now, point is where you are going to expect new infections to happen. And this graph, I mean, this is a global hotspot, right? As you have biodiversity hotspots, you have a hotspot for these pandemics or these emerging infectious diseases as well. And then this graph, which has been published in a world-leading journal, points towards India being one of the major global hotspots of these EID events, right? In fact, the emerging infectious disease events. Now, here you will find that earlier, if you find basically where these events were happening, they were happening largely in America, and then they were happening in Europe. And it is predicted that basically the India is going to be the hotspot of the disease spread, right, in not so distant future. Now, what are the drivers basically? I mean, this is something very interesting. You must have also talked about it. I mean, you must also given a thought to it. That is why happens. I mean, why did a pandemic happen, or why there is increase? I mean, I had showed you a graph. This is something very interesting. Now, you would argue that why basically there is such type of an upward swing basically in these pandemics. If they were basically happening at some basically regular intervals, why these events have increased? Why they have increased rapidly, almost exponentially they have increased. And actually, you need to ponder over this graph and then identify the reasons as to why a increase in the number of these infectious disease events is happening. And many of these infectious disease events, I mean, turning into pandemics, right? And people worked on it. They said, this is Low et al. This he also published it in one of the premier journals. And look at this. Land use changes 31%. I mean, prior to preparing for this lecture, I was not knowing that land use changes would be making such a significant contribution to spread of, say, pandemics. I was under this impression, experiments, the virus escaping the lab, this, that, so on and so forth. No. Look at this, land use changes. Land use changes, that means you are converting a forest, you are undertaking deforestation. Deforestation being linked to what? Being linked to spread of viruses. And this deforestation is happening before our eyes. Now, agriculture industry changes. Now you are basically, say, bringing about new crops. You are basically, even animal husbandry changes you are also bringing about. You are bringing about cows basically from Australia, sheep from elsewhere, right? You are basically now, say, rearing new kinds of animals, right? Yeah, there are basically changes. Those agricultural changes contribute to 15%. International travel and commerce. Now you are basically average bड़ी कंपनियां हैं आजकल. You are basically purchasing things online, right? And then who knows that this online trade and travel although has helped us in ways more than one, right? At home, we are basically looking at our products, selecting one, placing order. Without moving from our home, we get basically the delivery. But this in travel and trade, at a larger scale, is also contributing to the spread of viruses. Medical industry, war and famine. Look at climate change is the mother of all environmental scares. And many people say, even Shahid Jamil in India also says that change in the climate is going to be one of the serious basically contributing factors, primary drivers of, disease emergence in India. Human demography and behavior, right? Earlier our behavior with animals was one type. Nowadays, we almost basically have them as friends, isn't it? In our lap, right? Anyway, doing every kind of activity with these animals without ever understanding as to what we are doing. Breakdown of public health. This could also contribute to pandemics. Anyway, this graph basically points towards this fact that the causes basically that are responsible for these increase in the emerging, the infectious diseases, or such that are happening in our backyard as well. Land use change is something which is a very serious matter in Kashmir as well. If at all anything is serious in Kashmir, it is the land use. Why? Because you are bringing additional forest area under different kinds of cultivations, right? Naturally, you had wildlife there. Now you are having, say, increase in the population. Now increase in population would result in requiring more land for agriculture, for housing. The animals which were living in those forests, they come in contact with the human beings. You have much more man-animal conflict. In the process, they are transmitting. The human beings take up viruses and these causative organisms of diseases from them, and then many of those events basically, lead to pandemics as well, right? Now, this is something which is very interesting graph which we have to actually keep in mind. Now, this circle, if you will find that inside there are, say, microbes kept, isn't it? You have bacteria, you have viruses, right? And protozoa. Then they move into animals. This is a very natural process. If you remove this part, if you keep this part only, this is very natural. This is what happens basically in life. This is what happens in nature. You have microbes, you have other organisms, and then they live basically in perfect, basically, say, they are basically in a balance with each other, right? What you have done is that you have introduced anthropogenic environmental changes. You have brought about land degradation. You have brought about habitat loss. I have added only two. You could add climate change. You could add any number of things here. What you have done is that you have changed this interaction that was happening between these microbes and these animals. And as a consequence of this, what has happened is that you are now mixing everything together. You have animals, you have microbes, you have human beings together, isn't it? And then as a consequence of all this, and then why it is there? Because you have constructed a house there. It was a forest here. Now you have constructed a house there. Earlier, a lion used to come here. Now you are there. Lion may again have a basically visit there, occasional visit. And in the process would leave basically a virus there. And then you are able to pick up. You were not so far living there. It was a forest land. And then these microbes basically would live in company of these basically the other animals that were living in the forest. You degraded the forest, right? Came to actually reside there, either for agriculture or for basically, say, habitation. And Now you are very close basically to these organisms who are basically hosts of these natural hosts of these microbes. And there is a possibility now, there are increased probabilities of a spillover, that a virus or a bacteria would move from these animals into human beings. And then in the human beings, it will adapt and then will spread to other human beings, as happened with COVID, right? Now that means you are undertaking every such activity which basically is disturbing this natural balance. You are tending to be much more intimate component of basically this live biodiversity. You are basically now almost say moving into their habitat, right? And then in the process, what has happened is that many of the organisms which so far were basically hosting only these plants, animals, butterflies, animals, are moving into human beings as well. And then once in the human beings, 75% of them basically become infectious disease, and many of them turn out to be the more the contact, more the disturbance, right? More the alteration, more is the possibility of the spillover events, and more are the chances of say endemics happening much more at a much more faster rate than has happened in the past. Look at this, it's a small basically case, graphic from Jones, I have which published in Nature. Now look at this, you destroyed here now on this emergence of bat associated viruses emerged due to loss of bat habitat from deforestation and agricultural expansion. Now, earlier there used to be a forest, virgin forest, there used to be bats, and those bats would basically have viruses in them. It was their host. You basically destroyed the habitat of these bats, and actually the virus that was inside the bat, bats had to actually look around for their own survival as well. You got, bats could have moved to your locality. No, you moved to the locality of bats because of, say, the agricultural expansion, and consequently, whatever was in the bats, basically you inherited it. You somehow took certain of the viruses from that, and it resulted in bat-associated viruses. Bats are known to be cause of many of the basically viruses that cause a large number of basically. Look at the SARS. Early human cases of SARS were associated with contact with cats, either in the wild or in live animal market. Now, in our setting also, you have cat, you have pussy cat, you have this cat. Cats are very costly as well. You tend to live with these cats. You have brought about a change basically in our social setting. And you should remember that this association, newfound basically association of human beings with the cats instead of human beings, right, could be a cause of a new virus. And there is already an evidence for of a pandemic caused by SARS, right, which is said to be caused because of the close association of human beings with cats, right? Anyway, look at rabies. It was transmitted by bats to cattle and human because it was basically linked to forest activities in South Africa. Again, you basically brought about some changes in natural habitat. Forest fragmentation in North America led to increased risk of Lyme disease in humans. Nipah virus was linked to incentivification of pig farming. Pigs are going to give you a lot of money. In US and other places, you have huge pig farms, right? You send this food to everywhere, right? Now, these pigs basically, then naturally they have to be reared, they have to be basically fed, they have to be basically, somehow then culled. Then meat had to be, product had to be prepared. That means people came in contact with this pig farming and consequently led to the spread of Nipah virus. Likewise, pig farming has also been responsible for Japanese encephalitis virus. Likewise, Ebola outbreak in West Africa was a result of forest losses, right, leading to closer contact between wildlife and human settlements, right? Now, this basically gives you an idea that world's basically major, say, epidemics and pandemics have largely been caused basically by such type of activities which happen around us every now and then. And without appreciating this fact that these deforestation or intensification of the different kind of an agriculture, right, and then the cat culture, so on and so forth, this is basically one of the major reasons for increase in the spread of these viruses, spread of these disease-causing organisms. And if you continue with these activities, there is every likelihood that you are going to actually face, many such episodes. Now, this is a small example, right? Anyway, which is true of basically of a disease called as Kayasnor forest disease in India. Look at this. This is larvae. This is an adult basically tick. It is life cycle. It is eggs, right? From eggs, basically, there's adult eggs. Then it gives larva. Then gives nymph. This basically adult basically causes disease in human beings. This nymph would cause disease in these animals. From chimpanzee or it will move into human beings, and this is how it spreads. Now that means if you are getting in contact with basically, these basically adults live here. Now, if you get in contact with these on a large scale, there are more possibilities of this basically organism moving into human beings via this route also and via this route as well, and consequently resulting in widespread disease, right? Right. Now, many people have drawn certain parallels between two types of basically say biological phenomena. One, the zoonotic viruses like SARS, right, like this COVID-19, and biological invasions. We work on biological invasions, and then we find a lot of similarity between what is happening in SARS and what is happening in an invasive species. Look at this. You have evolution of a pathogen. It was a pathogen, say, for example, it was somewhere, right, in one of the hosts. It's a, for example, it was in rats. It spilled over, then it moved to human beings. Then human beings, because of travel, basically they can travel across geographical barriers, right? Earlier the geographical barriers were there, people would not travel, it would move to many people. Now virus becomes an epidemic. Why? Because it causes, basically it spreads far and wide, and then it actually it causes a sort of a pandemic. Then there is a response from the government. Same is true here in biological invasive species. You have a species, say, moving from somewhere, you have got it from somewhere, you have got it from here, China, Wuhan. You have got it from somewhere, you have introduced it in some place, it remains there, evolves, right? Then gets in contact with human beings, has a human interface. Human beings are basically able to carry it to other places, which otherwise it would not have been. It could be intentional, it could be unintentional. Then it spreads as it was spreading here, and then ultimately you put in place certain, say, mechanisms of controlling them. That means whether it is a sort of a virus or it is any other invasive species, all of them have the potential of causing one or the other harm to us, and with economic, social, and other costs as well, right? Look at this. Now you would argue that viruses alone are moving from one place to another. No. Vascular plants are also moving from one place to another. Birds are moving, fishes are moving, mammals are moving, arthropods are moving, mollusks are moving, crustaceans are moving. And look at basically, it is not true that they are moving from one place to US or tropical Asia. No. You will find that all across the world, every kind of organism is moving from one place to another, and there is an exponential increase. That means Kashmir, that India would also be basically getting what many, say, species other than viruses from other parts of the world. Why? Because there are drivers basically available at this time, which promote basically the spread, transport of species from areas to the other areas, which otherwise was not possible. Earlier, through natural means, these species would not have moved. Now look at this. In India, we work only on plants. 1,599 vascular plants in India are not native to India, they are from elsewhere. 571 plants in Kashmir are, say, not plants native to Kashmir, instead have come from elsewhere. Now, if they have come from elsewhere, there is every likelihood they would have carried along with them their basically pathogens as well. This is possible. Likewise, if people work on animals, you will find a large number of animals have moved from other continents to us. They have moved along with basically these pests. Now, if you are continuing increasing these transport of species, notwithstanding directly the virus, you are increasing basically the chances of spreading the disease. Look at, you can have intentional, you bring them from agriculture, forestry, botanical gardens, or you have unintentional introduction, the proper use get carried with your, say luggage, so on and so forth, right? Look at this. Look at this part. Unintentional is one of the major pathways of transport of these species to India and Kashmir. And after unintentional, which you need to actually say, take note of, is basically the ornamental part. Now, the plants that are being usually transported from other parts of the world for the purpose as ornamentals, they are also the source of transport of propagules of other species, which could be problematic. Now, look off this garden, tulip garden, I mean, could be majestic, but keep in mind, with the types of quarantine, say, facilities available, with these tulip propagules, you may be getting a lot of these species, pests, vertebrate, animal, I mean, these viruses, bacteria, I mean, any kind of basically these species you will be getting into Kashmir. Although apparently you had thought that we would basically be beautifying Kashmir, having Asia's famous, they say, tulip garden, and in the process, unintentionally, you may be transporting a very large number of species, which in due course of time may be problematic in ways more than one. And naturally, and unintentional is the measure mode. That means unintentional points towards the fact that the screening regime is not very effective here in Kashmir. I know that we move from basically other places to Kashmir. Nobody checks for these propagules. As against this, if you move from, say, India to some other developing country, they would ask you for seeds, propagules, right? Which may spread, so on and so forth. Now, point is that we, since have data only available about plants, we tell you for certain that plants have moved from other places. Plants per se are a problem. You see Dal Lake, there are problems. I am saying that with these plants, there could be other pests also coming, which are waiting in the wings and may spill over basically to human beings. And then ultimately, right? Right? Now, vectors, hosts, invasive species, and people all live in close proximity and may be a recipe for disease. You have everything basically now together, and consequently, you can have disease, right? Now, you would argue that where scientists are sleeping, where they're not basically warning people of the deluge, which was likely to happen, right? This could also be an argument with the people that why scientists basically sat, right? And then silent and not warn basically people of the impending problems. It is not a fact. In 1997, around 1,500 scientists signed basically a warning, and they called it as World Scientists' Warning to Humanity. Right? And this was written by the Union of Concerned Scientists, wherein they clearly laid out that these are the, say, issues which you need to be confronting at the earliest, or else you are going to end up in a disaster, right? This is 1997 April. Scientists warning people of what is going to be happening in future. Now, this is much more interesting basically than the earlier one. Now, this ripple in 2017 evaluated as to what was done with respect to the warnings that these scientists had given in 1997. Look at, I mean, the gray part is the period when this appeal was made. The dark line is the period beyond that. Everywhere, look at carbon dioxide emission. They have warned that carbon dioxide emission is going to be an issue. Nothing was done. Instead, carbon dioxide emissions has increased per year. Look at temperature change. They had said that temperature change is going to be a problem. Still, it has increased. Population, increase in size of the population, then feeding it, additional land area under cultivation is going to be an issue. It has shown again an increase. Total forest area, look at the kind of decline. They had said that their decline is not good. Look at vertebrate species abundance. This is also declining. Now, despite this warning by the world's acclaimed scientists, corrective action was not taken. Instead, we moved on the path basically of so-called development, increased basically carbon dioxide emission beyond this limit, right? And then temperature change, then population, then tourism, I mean, total forest area. This is what basically we got in 2017, right? And then, which means that we have not heeded basically this warning. We have continued on the path, right? Anyway, and as a consequence of this, these people came out with second notice, right? Isn't and it is titled as World Scientists Warning to Humanity, a second notice, right? Scientists warning of also invasive species. This was published very recently in 2020 in Biological Reviews. They said that this is going to be an additional problem. Basically, earlier you were not having this issue. Now this issue is further compounding the problem. You need to take this into consideration, right? Now, what is the way forward? Now, WHO says that the way forward is One Health, right? They say that you can't segregate things. You have to have an approach, right, by which you are implementing policies, programs, right? In a cross-sectoral manner, you are communicating with every sector, be it environment, be it, animal health, be it human health, right? Anyway, if you are working on human health only, to the exclusion of animal health and environmental, you are not going to achieve the goal. If you are working only on environmental health to the exclusion of animal health and human health, you are not going to achieve the goal. Same is true of the other thing as well. Now, One Health approach is that you have a cross-road sector, you are taking care of environment, you are taking care of animals, and then you are taking care of basically animal health, human health as well in terms of infrastructure, so on and so forth. Then alone, you are going to basically be having a healthy basically environment, right? Wherein the possibilities, expectations of these epidemics is going to be less. Now, so far, you will agree with me, we have basically worked in our own silos. Human health, basically, scientists would not pay heed to environment or pay to heed to animal health. They would damn care about these two aspects. Likewise, these two aspects, these environmental scientists would pay least basically give importance. As well, botanists would pay little basically importance to animals that he finds around it. Anyway, the take-home message is that we shall have to actually look at everything collectively. This is a new awakening in WHO also. Their recent document, if you log into their website, you will find this there. They are saying that we need to actually follow this approach, if at all, we have to actually tackle these viruses, right, successfully, right? And then to this basically, the triangle, this person, Hulmi, in 2020 added something extra. He said human health, animal health, plant health, and environment, all important. And then he links everything with these invasive species. Why? Because they are very widespread in the world as well. In Kashmir, in India, everywhere they are not only deleterious themselves, but they are reservoirs and vectors of human disease, such as recon dog is a vector of human disease, right? Likewise, basically invasive weeds, basically like multifloral rose has been basically a vector of human disease. Feral crops as alien weeds and alien plants as weeds of crops, common ragweed, right? They are influencing the human health in ways so far not appreciated. Now emerging alien zoonoses linked to livestock, for example, in Rift Valley virus. There is an invasive livestock species which is spreading fast, and that livestock species is spreading the virus as well. That means everything together is going basically to, this he calls as one biosecurity, a unified concept to integrate human, animal, plant, and environmental health is the solution to the problems that we are facing and which we expect to increase in due course of time. The take-home message is that our solutions are in nature. This was basically, in May, you have this World Biodiversity Day on 22nd May every year. You have International Day of Biodiversity celebrated. Since it was COVID, it was online. And then the slogan for this year's Biodiversity Day was, our solutions are in nature. And then this and this, it brings it clearly, it lays it bare that if at all solutions for these pandemics have to be found, these have to be found in the nature itself. If you take corrective measures, basically, you are going to actually halt to a larger extent these pandemics. If not, you should take it from us that this is not going to be the last pandemic. We are going to actually face many more. I end up with a quote of Edward Jenner. He says the deviation of man from the state in which he was originally placed by nature seems to have proved to him a prolific source of diseases, right? Now, in 1798, a thinker, right, like Edward Jenner says that if you are deviating basically from the state in which you were placed in nature, you are going to end up basically facing lot many diseases, and that is what has happened, right? Anyway, now all with notwithstanding the developments that have happened around us, notwithstanding the revolution that has happened around us, but we need basically this virus has somehow brought this point strongly home to us that I can still surmount basically the human race along with this technological extravaganza. If at all you are not going to actually say live in harmony with nature, the nature is going to strike back and strike back with vengeance, right? And then would basically say somehow bring many developments that human beings have made and that human beings brag of would be brought into question, right? And this virus has done that. It has brought many things into question. And those questions basically demand answers from us. They demand a lot of thinking from us, right? And then ultimately, the ultimate solution lies in looking towards nature, setting basically the norms, of nature, right? Setting the norms for the human beings also vis-a-vis its interaction with the nature, and there is expectation that we are going basically to live in harmony with the nature, with animals and other things, or else we are going to meet the fate that we met because of this small, tiny virus which we cannot see. And then the might of America was decimated by this virus, right? This is basically the message that basically has to be taken home. And I do not know what is going to happen to the world order also because of this virus, right? Right? Feudalism was decimated because of a virus. There is a possibility a new world order may emerge as a result of this virus, right? Such is the impact of these viruses, and many such are going to actually we are going to see many more of them, and we are not prepared basically to see many more of them. Instead, we need to actually put things in order. We need to put our house in order, do whatever we can at an individual capacity collectively to see to it that we basically live a very comfortable life, right? And then along with the other organisms with which we share this earth. This, I thank you. I mean, it is to be 12, 11. Any questions?
Thank you very much, sir. As expected, a very detailed, a very comprehensive account of the COVID-19 pandemic and its various implications. The amount of hard work that has gone into the making of this presentation was quite evident. In fact, the amount of hard work and labor that has gone into the making of each and every slide. As always, you have been very scholarly, very professional in your approach. And we have been hearing a lot about COVID-19 pandemic over the past several months. But most of the discussions have been restricted to the health impact, the economic impact, the geographical impacts, but hardly we have heard much about the ecological, environmental impact, and the concept of One Health that you have come up with and you have discussed, wherein not only the human health, but the animal health, the plant health, as well as the environmental health assumes equal importance. In fact, sir, your presentation has not only answered a whole lot of questions, but has even led to a whole lot of new questions, which our learned teachers can explore and they can research and they can think about and further, try to dwell upon them. What are their implications and repercussions? And the things like you said, it could lead to a new world order, and it could lead to a whole lot of new issues. So it all was highly enlightening and highly interesting. And the way you discuss the whole evolution of the pandemics in the history of the world, and the evolution of the transmission of diseases, the impact of the human settlements on the ecological environment, on the environmental health, and the spread of pandemics. This particular presentation has been, has made us quite inquisitive about a whole lot of questions regarding this field. And this emphasizes the need for interdisciplinary research, because no matter to which field we belong to, these are the issues that concern all of us. And we need to study them in depth. We need to explore them in depth and do research on these issues. So I'm sure, sir, the participants might have benefited a lot. Now I would request the moderator of the session, Dr. Sabira Musa, questions from the chat window or directly invite the participants to ask the questions so that we Professor Ishaq can answer the same. Over to Dr. Sabira Muzaffar.
Yeah.
Sabira, can you hear me? Okay, so let me have a look at the chat box. I think Dr. Sabira, we are not able to hear her. Maybe there is some bandwidth connectivity related issue. So first question is, which I can read from the chat box. Why is there steep increase between 1980 to 1990? I think you have partly answered this question, but would you like to add anything else, sir? Why there was a steep increase between 1980 to 1990 in the pandemic?
Yeah, I will. This is the slide that basically somehow has prompted this question, right? Anyway, look at this. Now, you should basically appreciate the fact that from 50s onwards, we basically somehow took a plunge into a new type of a global economy. India also opened up. So China also opened up. I mean, it was a communist country. It was not opening up. It would do things within its own, jurisdiction. The world opened up. It became a global village. I mean, people traveled throughout the world. The money also came to people. I mean, people became affluent also, and then they started moving around. I mean, how many of us were moving the way we are moving now? Now, point is this: that it's a fact that after industrial revolution, we harvested benefits of industrial revolution. We basically somehow learned new things of doing, right? We traveled a lot. We took to different kind of agriculture. We increased our capacity to, say, dominate the earth. That also increased, right? And as a consequence of all this development, economic development, which happened beyond 60s, 50s rather, it basically, say, triggered, which Alvin Toffler called as third wave. I mean, it basically triggered many forces, right? Anyway, and we never knew that those forces are going to unleash these viruses as well. Now, say, for example, deforestation, millions of hectares of land are deforested world over. People understood that forest is not important. Let us have a crop cultivated there. Human population increased. Now, naturally, you had to feed this human population. Now, agriculture revolution, new varieties, new fertilizers, new types of, say, implements, right? I mean, everything happened around this time. And then the capacity of the human beings to dominate Earth also increased. Now your agricultural productivity increased, your population increased, your industrial output increased, your travel increased, your tourism increased, right? Your per capita, say, consumption increased, say, your number of vehicles increased, so on and so forth, right? Anyway, now as a consequence of this, all this together, the contact between the human beings and the wild, basically, life, which includes animals, plants, so on and so forth, right? It increased. Now, earlier you were confining yourself to, say, for example, a town. Now you have life almost in a forest. You have converted that forest also in a town, right? And then the organisms that were inhabiting that part, now naturally, I mean, they have also to live in this world. Now, a virus which does not find a host, where will this virus go? You have removed bat, you have killed waste, you have used pesticides, you have killed 10 number of organisms. Now they were hosts of n number of these viruses. Now, after all, this virus has also, it also tries to perpetuate its generation. That is what all species do. And many of them might not have succeeded, but some of them succeeded in bringing about a particular type of a mutation and started living in another host. When that host also got eliminated, they mutated and moved into another kind of a host, right? Anyway, more the contact with basically the wildlife, more the human-animal conflict, which is increasing, which is a priority in India. Now, more basically are the chances of the spread of these viruses. And look at basically, I mean, look at HIV, there is a huge story about chimpanzees, so on and so forth, right? Look at basically the H1N1, right? The trade the Chinese do in these animals. In Kashmir, we don't consume such type of animals. But in China, you will find that there are huge markets basically of these wild animals. Now that means people go there, collect them from somewhere, bring it to a market. Lakhs of people basically use those basically these animals, and there is every likelihood that basically it has spread. Now, point is that development happened, and in the basically the something happened basically. I mean, while we were developing, where we were basically doing something good, unintentionally many things also happened, which are basically now which one such negative thing that has happened in the process of development has been the have been the unintended increase in the contact between the humans, beings, and animals, and as a result of increase in zoonotic disease. There are many people who are raising this. Hope I have answered your question.
Thank you, sir. There is one more question by Dr. Jyoti Taneja. She's asking if we look at the mortality caused by COVID-19, as compared to rest of the pandemics, it has shown showing very high number. The remaining pandemics have shown considerably higher mortality, but the current one is considered to be the biggest pandemic ever, which has affected whole world on the whole. Are we failing against viruses? And she added, are we forgetting pandemic like 19th century has resulted in 50 million plus deaths, but we are failing, what strategy is needed? Are we failing?
Yeah. I understood. I mean, look at basically the Ebola, right? Anyway, I mean, there have been pandemics in the past also, right? I mean, people like Karl Marx, right, have written also about these pandemics, right? They are natural population control agents. I mean, they used to write like this, right? Anyway, issue is this, that in a world basically, which is, I mean, earlier pandemics, yes, disease happened. I mean, people got killed, 60 million people, 56 million people died because of smallpox. Now, they basically were restricted to Europe only. I mean, Europe got affected. It's not like this that every country got affected. Now, what makes novel coronavirus very distinct than rest of the viruses is somehow it brought whole world to the grounding halt. Now, your supply chains got disrupted. You are interlinked now, right? Now, people are traveling, people are studying elsewhere. Everything got basically disrupted. Now, such type of a disruption in basically, say, 21st century, because of a virus, runs contrary to basically the economic model that we have. Yes, it is a fact that smallpox, cholera, Black Death might have caused more deaths, but you take it from me, but the economic damage that this virus caused, the anguish that it caused, that the emotional stress that this virus caused was far more than any kind of previous viruses. That is the reason why people nowadays ask a question: what basically is globalization good, or one needs to basically put a question mark also on it, that if at all anything happened in a very small remote place of, say, Wuhan, people suspect that it happened there. It moved so fast. Had there been not these aeroplanes, it would have taken 1 century to move to Kashmir, right? It moved in a jiffy. And then the environmental costs, the economic costs basically of swine, I mean, this COVID-19, I mean, far more than any of the pandemics that you had in the past. One, that if people have died in the past because of a pandemic, does not make any justification for people dying because of a pandemic now. Now, issue is that, have we done something? Are pandemics natural? Yes, they are. But what we have done is that we have increased basically their incidence, that is of your making. Now, you have seen the graph that because of your activities, what you have done, you have increased basically the incidence of pandemics, right? And then you may further increase the incidence of pandemics if you proceed on the path of development that you have chosen, that has been propagated as the only path basically of salvaging the humanity, right? It's the fact that yes, mortality has happened, but together with mortality, economic costs, job losses, right? I mean, the emotional distress, people got separated, has been tremendous because of this novel coronavirus. Thank you. Anybody? Said. Said Mir, yes.
Dr. Sabira
Sir,
has.
yes, Zafar Sahab, I had this question regarding, you had this one slide. Can you please go back to that? The one
Which
where
one?
there are the decade-wide emerging diseases.
Right.
The where there was this one decade, 1940 to 50, then 50 to 60.
This one?
No, the one with the graph, yeah, bars. Yes, exactly. If
This
we see
one?
there the number of this EIDs, no, the
Right.
previous one, which was already there. जो दो
This one?
डबल साइड में बार
This
था
one?
अभी जो आपने लगाई थी.
This one, this
Yes,
one.
sir. Yeah, exactly.
Right.
Here
Right.
there is a sudden increase between 80 to 90, then it decreases 90 to 2000 again. I wanted to know whether
Right.
there was some specific reason for this.
Not a specific reason, right? Anyway, reason is that this is a paper in Nature, right? Anyway, point is this, that the specific declines between years is not something very important, right? Important is the overall trend. The trend is, and I have also not seen this paper with great detail, right? Anyway, as to why it happened, but in this graph is bigger and this graph is smaller. But I used it basically for this purpose to bring this point home, that there is basically an increase in the number of these infectious disease events. And then we need to basically say examine these graphs and to bring out the factors which are responsible for this, right? I mean, somehow this basically graph I use it to lay foundations for my lecture, right? Anyway, and then somehow they point to the fact that viruses are, look at taking up here, viruses moving, viruses moving, right? Anyway, now our understanding of viruses was also improved a lot, right? But nevertheless, that viruses are also very tricky, right? They mutate, a very simple genetic material, they mutate, so on and so forth. The moot point of showing this graph was that we can basically bring this trend downwards. It should have been beyond 2000 as well, but it was only published in 2008. Now, in case it goes down, good. So far, it has been basically showing upward trend, and we have to basically bring this down. And let us hope that this 2000 marks basically the beginning of that downslide, right? And then we are able to somehow get hold of these viruses. But the activities that are happening around us do not point towards the fact that there would be any decline in the number of these episodes of these infectious disease events in near future. You are still continuing with the market that you run in China, right? What the people would do. Point is that this is telling you something, that what you are doing is not wisdom. It is questioning your wisdom. This virus has questioned your wisdom. And we need to basically relook at, our steps of our model of development, right? And then that way, that this virus has done a sort of a service as well. That it is questioning basically the very wisdom of the human beings, that you are claiming that I have done something great. Let me basically tell you that how much great you are, that you are unable to control me. Unless and until you do not live in, in company with nature, right? In harmony with nature, you are going to actually face these consequences.
Yes, sir.
So
in
continuity with that answer, that virus is claiming that humans have not been able to control it, there is one question asked by Dr. Mohammed Anis, who says that if the vaccine somehow works on the virus at present, can a virus change the host to some other organism for its survival?
Sure. I mean, that is a fact. I mean, viruses do it. Viruses do it quite often, right? Anyway, now what viruses, I mean, all these viruses never had the human being as the host. They never had the human being as the host. They were somewhere else, basically in an animal. Then animal and human beings, I mean, the other animals came in contact. It moved basically, for example, a bat to a livestock animal. Then from livestock to the human beings, it is possible that you can have a strain of, for example, COVID-19 at this time surviving in some other host. I mean, in ecology, we say fitness. There is a term called as fitness. The ultimate aim of any organism on this planet Earth is to perpetuate its generation. You have a plant producing very showy flowers. The ultimate aim of this plant is to perpetuate its generation. Fitness is measured by number of individuals that a species contributes to future generations. Likewise, virus's main aim is to survive and to perpetuate its generation. It will do anything in the world to survive and then to perpetuate its generation. And in that process, it can basically very easily mutate and get into another host. This is a possibility.
Yeah, one more question by Mr. Shaukat Ahmed Pala. How would you rate genotypic plasticity of this pathogenic microbe in causing pandemics? Genotypic plasticity of this pathogenic microbe.
Right.
How do you rate genotypic plasticity of these? Maybe Shaukat Ahmed Pala can explain it. Shaukat Saab, can you unmute yourself?
I understood it, what he's saying. Right. Now he's saying that the microbes basically have a very simple genome, and then they have their mutations are much more common than the say other advanced genomes like animals, like human beings and plants. Now, it's a fact. I mean, after all, it is a fact that there are viruses which basically, I mean, mutate, they grow, so on and so forth. It is basically one of the factors. But the other factor is that if a virus mutation doesn't get a host, where from it will get the host? Well, the point is this, that what you have done is that this let us take the example of this, right? At this animal, which is suspected to be one of the hosts of this virus. अरे भाई ये virus, ये animal जो था जंगल में था, you should have allowed it to live in the jungle, and then it was having this virus. So, okay, no issue. What you have done is that you have got basically this virus for your economic reasons to your market here, right? If you would have left it there, it was good. I mean, you are getting directly now wildlife also basically to this market. And she is there, right? People are here purchasing, and you are now, what you are doing compared to past, you are increasing many-fold now the contact between basically that wild animal which used to live in the forest and in our childhood, which we used to dread, right? We have mastered these forests. I mean, we are say running these lines also out of these forests. You are bringing it here, and actually you are increasing the chances of contact between the animal, his viruses, bacteria, pathogens with the human beings. There is every likelihood, possibility, they may move into human, they may not. But once this contact, this is simple probability, more the contact between the wild animals and the humans, more is the probability of transfer of these organisms. And more is the probability of one or the other of these, say, getting basically, say, converted into something of a disease-causing organism. Yes, underlying genetics also basically say helps it to somehow mutate and move and survive in this new host. That also is a fact. But this is also a fact because the viruses had basically this ability long back also. Why this graph then? Why this increase, sudden increase? Why this increase? That means here also viruses had basically the same genome. Here also the viruses had the same genome. That means you did something here because of which this graph moved upwards. You have not to look basically at this natural part. You have to do what you have done, right? You have done, I mean, you can't do anything about the genome of a virus. And then so many viruses, many of them unknown. But you can basically retract your steps regarding what have been contributing to this superadaptive. I believe I understand. Anybody?
Right, sir. There was a joke circulating on Facebook that in 2021, human health will depend a lot on what Chinese eat this year. So to what extent is that correct? Like there is also one question by Dr. Zubair. The best precaution would be to promote and encourage indigenous species than the introduction of exotic species. You have already thrown some light on that while giving examples of cats and all.
Right.
Does it really depend on what Chinese eat this year that will influence the human health across the world?
Well, yes, right. I mean, I'll explain it slightly, I mean, differently as well. Now, it is also a well-known fact that it is not your income which determines your expenditure. It is somebody else's income also which determines your expenditure. Now, if you are, purchasing a bicycle for your child, right, then the other child also demands the same bicycle from his parents. Whether those parents have that money or not, they also purchase it, right? Anyway, likewise, what China is doing, I mean, China is going to be a global economy. They are basically say, man, they do trade with every country. In 24, they are going to surpass the US. And if you live in a globalized world, then you have to depend upon Chinese goods. And once the Chinese goods basically come, who knows that what is along with them? I mean, viruses are something which you don't see anyway. Now, whatever Chinese do or whatever Americans do for that matter, because they are bigger economies, they have a larger economic influence. Yes, it is a fact that they would basically determine as to what is going to be the fate of the world, isn't it? Would be determined largely by Chinese, and they are even eating bloody habits as well. Anyway, regarding exotics, now one has to basically understand is that all exotics are not bad, right? Rice is an exotic species, wheat is an exotic, maize is an exotic species, but we have at this time methodologies available by which we can very easily say that which of these exotic species is going to spread. We are concerned about not all exotics, we are concerned about a subset of exotics, which are called as invasives, which spread. Now, say for example, chinar in Kashmir is an exotic species but didn't spread. But look at basically the weeds in Dal Lake. They are also exotic, but they have spread. They have spread far and wide. Look at kikar, isn't it? Rubinia pseudoacacia. It has come from elsewhere, but it is spreading. That means one has to make a distinction between those exotics which do not spread. We have currently technologies available, methods available, protocols available by which we can determine it, and those which will spread. Those which do not spread, I mean, after you are screening them properly, thoroughly, you can allow them. You can allow them for some time under some sort of strict, basically quarantine, and then you can put it in the market. Regarding, say, others, just but what is happening is unintentional species that you are bringing up. Anyway, anybody? Anyone else?
Please continue, sir. Is there any other question? Would any other participant like to ask any question? I don't think there is any other question. Moreover, we are running short of the time, and we have, I think, up. So it's back to Dr. Sabira.
Geer Sahab, I have written a question in the chat box.
Feel free to ask. Please ask. Go ahead.
Zafar Sahab, Assalamu alaikum.
Assalamu alaikum, walaikum salam.
मैं तारिक
welcome. Dekha, can we think and collaborate on transgenic plants expressing antigens, right? You see, we can, I mean, after all, what has happened is you cannot turn back the clock. You have spread the viruses, right, because of globalization. That part is agreed, right? And in that context, yes, transgenic plants which would produce antigens. Now, say, for example, if we take rice, we are rice eaters. Now, if rice is basically with something which is a sort of an carries something which is a sort of an antiviral, something of an antigen, I mean, it would be very useful. I mean, this has opened up new ways of thinking, new vistas of research as well, this COVID-19, right? Yes, we can. I mean, there is no doubt about it.
I mean, this is a new, actually new approach that could be, actually.
That could be, yes. That could be, yes.
Yeah.
I mean, you could be, I mean, tailor-made, isn't it? I mean, foods, I mean, kuch na kuch to karna hi hoga, bhai. After all, human ingenuity is also will equally match it, right? ऐसा नहीं है कि the virus would basically somehow suppress human ingenuity. Maybe it throws basically, ये भी हो सकता है कि that this virus throws a new host of opportunities, new course of development, new course of science, entirely exciting as well, right? That also is possible. Virus should be holding.
Researchers and plants, and the plants as a model to understand.
Anybody else?
This.
Over to Dr. Sabira for presenting the vote of thanks. Dr. Sabira.
Thank you so much, sir, for this thought-provoking presentation. Professor Rishi has given an insight of impact of COVID-19 on economy, education, health, and social life of the people. Sir took us back to history where we have witnessed so many pandemics. He also surprised us with the increase of zoonotic diseases from 1940 to 2000, and which is further expected to increase in future. Sir further elaborated on reasons of this increase in infections and turning them into pandemics, like changes in the land use patterns, globalization, agricultural and industrial changes, our interaction with pets, and so many other things. Your lecture was more like a warning to all of us, sir, in terms of our preparedness to these pandemics. You emphasized on One Health approach, which needs to be adopted for taking care of environmental health, animal health, and human health in order to keep ourselves safe from such dreaded events. Lastly, I want to express my gratitude to you, sir, for sparing the time and enlightening us with this wonderful, informative presentation.
Thank you.
Thank you, sir.
Thank you, Ayush,
Thank you.
and all my colleagues. Thank you. So nice.
Thank you for accepting our invitation, sir.
Yes,
And
it's always a pleasure.
of comments in the chat box appreciating and expressing their heartfelt thanks to your presentation, sir. Yeah, Dr. Sabira.
Scientist.
Thank you, sir. Now, Dr. Sabira is requested to take up the participant session in which Dr. Abid Majid Bande is going to present. Dr. Sabira, can you please start the participant presentation session? Dr. Abid, I'm not able to hear you. Yes.
Assalamu alaikum, sir.
Alaikum salam. So I think Dr. Sabira somehow has got disconnected, perhaps. Dr. Sabira, are you there?
Oh, no issue, sir. I can start.
Yeah, we will be having, Dr. Sabira, please introduce the participant who is going to make the presentation as is visible to you on the screen, I think.
Yes, sir. I invite Dr. Abid Mande, who is from the Islamia College of Science and Commerce. Dr. Abid has done his postdoc from University of Arizona. He is a Fulbright fellow, and he will be delivering the presentation on a new tool to disease diagnosis and treatment. Over to Abid, sir.
Yeah, thank you so much. Assalamu alaikum, everybody. A warm good afternoon to all the participants within and outside the state. So I'm Dr. Abid, as introduced by my colleague. The topic that I will be delivering today, it is bioorthogonal chemistry, a new tool to disease diagnosis and treatment. So, my dear colleagues, a nation's development is always linked with the technology, and technology happens when there is advancement in science. For development to happen, science and technology go hand in hand. We know science is the study of knowledge and analyzing and understanding the facts. Technology is basically the application of this scientific knowledge. For any successful economy, we have to have development in science and technology. And then implementation of technological breakthroughs needs better policies. And for policymakers of any nation, Mahatma Gandhi once said, recall the face of the poorest and weakest man you have ever seen and ask yourself if this step you contemplate is going to be of any use to him. That means our policies should be such that any development we take, it should be helpful to the poorest of the poor. The quality of policies should exactly fulfill the conditions that Mahatma laid. As a general rule, investing in healthcare results in economic development and thus the overall development of the nation. Now, what has science and technology done till now? We all appreciate that science and technology has resulted in remarkable development in education, communication, agriculture, industry, healthcare, etc. The global economic output has increased almost 17-fold in the 20th century, which is called the century of science and technology. Now, life has been made a lot easier and better with the advancement of medicines and analysis and the diagnosis of diseases. Now, with this short introduction, I just want directly to go to my topic, that is bioorthogonal chemistry. which is a new tool to disease diagnosis and treatment. Now, what actually bioorthogonal chemistry is? Bioorthogonal chemistry refers to any chemical transformation that can occur inside living systems without interfering or interacting with native biochemical processes. So, in nutshell, it means that in this type of chemistry, what you do chemical reactions within living systems. You play with the cells, but the chemical reactions should not interact with the native biochemical processes that are always going on in the cells and in the body. So the term bioorthogonal chemistry was coined by Caroline Bertozzi in 2003. Thus, it is a recent concept and has been exceptionally successful in diagnosis and treatment of various diseases. Now, this bioorthogonal chemistry involves chemical reactions which are very simple, but the beauty of these reactions is that they are carried out in a non-interacting way within a very complex biological environment. Now, she is Caroline Bertozzi. I had the chance to work with one of her first postdocs. So she works at the University of California, Berkeley, and she is the one who pioneered in this field, and she introduced the term bioorthogonal chemistry in 2003. I am quite sure that after some years, she will be awarded with the Nobel Prize because of the huge impact and applications of this bioorthogonal chemistry, the field that she has introduced. Now, for any bioorthogonal chemical reaction, means a chemical reaction which is taking place within the living systems and doesn't interfere with the biochemical processes, there are basically two steps. In the first step, a cellular substrate, for example, a glycan, a protein, a lipid, an enzyme inhibitor, or anything that is within the living system, it is modified with a bioorthogonal functional group, which is called a chemical reporter, and it is introduced to the cell. The chemical reporter must not alter the structure of the substrate dramatically to avoid affecting its bioactivity. Then in the second step, a probe containing the complementary functional group is introduced to react and label the substrate. For example, we have a cell, metabolic or protein engineering. We do this process. Through this process, what we do, we introduce a reporter X, say for example X, on the surface of the cell. Now, a particular chemical reaction is carried out to introduce this chemical reporter on the cell. Now, when this X is introduced on the cell, a complementary chemical entity, which is, say for example, Y, attached to a probe, which may be an affinity probe, a fluorophore, or anything which may ultimately give us an information about the cell, about the environment, or something like that. So this chemical reporter X in the second step is reacted with this Y, and this X and Y, they react together, and this probe is inserted, this probe is attached to the cell through the chemical reaction between the chemical reporter X and the complementary group Y. Now, I will show some of the examples wherein this chemistry has been done. But before that, I want to tell you what are the requirements for bioorthogonality. What are the requirements that a bioorthogonal chemical reaction must fulfill? The bioorthogonal chemical reaction, it must be selective, means it must take place at only the selected target. It must be biologically inert, means it must not react with other biochemical processes. It must be chemically inert also. It must not react with any chemical entity before reacting with the chemical reporter. Its kinetics must be very, very fast, because otherwise it will be metabolized by the time it reacts. So it must be fast. The reaction must be biocompatible, and there must be an accessible engineering by which this whole chemistry can be done on the cell or on any biomarker. Now, types of bioorthogonal transformations that have been carried out successfully till now. They are nucleophilic additions have been carried out within living systems. Strain promoted 3+2 cycloaddition reactions have been carried out. I will be just discussing my topic with reference to this second one, that is strain promoted 3+2 cycloadditions, because I have a good expertise in this, although I do not know much. I cannot claim that I know every bit of this, but I have worked in this area, and some of the knowledge that I have gained during my postdocs, I will be just discussing these reactions just to explain the bioorthogonal transformations. Then there are Diels-Alder reactions that have been bioorthogonally carried out. Metal catalyzed couplings have been carried out. 2+2+2 cycloadditions also have been reported. Let me go to the second part of the second type of the bioorthogonal transformations, which is strain promoted 3+2 cycloadditions. Now, before going to this and making you aware about what it is actually, I just want to tell you that this strain promoted 3+2 cycloaddition, it is a type of green reaction. If carried out under normal laboratory conditions, this is a green chemical reaction. You know what green chemistry is. I don't want to go into the details. And then amongst the green chemistry, recently there has been a new concept, one type of reactions which are called click chemistry reactions or click reactions. They are very, very important. Click reactions are the reactions which just happen within a click. Within a click means within a fraction of a second these reactions take place. But the best example, which is called the cream of the crop of click reactions, that is a reaction between a terminal alkyne, I'm showing over here, and an azide. So azide alkyne cycloaddition reactions, which result in the generation of these triazoles. They are called, but these are copper catalyzed reactions. So these reactions, take place very fast. The catalyst is copper 1. So these are called copper 1 catalyzed or copper catalyzed azide alkyne cycloaddition reactions, which result in the generation of triazoles. I have published many papers on these reactions. So these reactions are very, very fast, and 0.1 or 0.2 mole% of this copper catalyst is used in the reactions, in the laboratory reactions, when this reaction is carried out. But so this is called a click reaction because it happens in water. It requires very small amount of the catalyst, and this reaction is very, very fast. Its handling is very, very simple. The yield of the product is almost 99%. So these are some of the attributes which are the click chemistry, which click chemistry reactions need. So this is basically the copper catalyzed azide alkyne cycloaddition reaction, but carried out under normal laboratory conditions because we use copper as a catalyst. However, if we want to do a reaction between an alkyne and azide within a living system, there you cannot use copper because it will be detrimental in the biological system. Thus, we have to introduce something wherein this reaction will be carried out without the use of any catalyst. So that's why we use this strain promoted 3+2 cycloaddition between an alkyne and an azide. I'll show you. So strain promoted 3+2 azide cyclooctane cycloaddition. So this is a biomolecule which has been labeled with an azide through a chemical process. Now this N3 is over there. Then you have cyclooctane labeled probe. You have a probe, the yellow colored probe, and it has been attached with a cyclooctane. Cyclooctane, as all of us know, it is a highly strained system. So whenever it finds N3, so this is a This is an ene and this is a diene. So ene and diene reaction takes place. So this click reaction takes place without the use of any catalyst. So wherever cyclooctane finds this azide, it automatically reacts with it without the use of any catalyst, and this reaction is almost explosive. It was discovered by Wittig and Krebs in 1961 that strained cyclooctane reacts with an azide like an explosion. So whenever the two meet, wherever they meet, within a lab, within the lab or within biological systems, without the use of any catalyst, they react and they produce this triazole. So the triazole that we were producing over here after the use of a catalyst, now the same thing is obtained without the use of a catalyst, but the condition is that the alkyne has not to be the terminal alkyne as was the case earlier. Now it has to be a cyclic octane because this cyclic octane is highly strained and it explosively reacts with the azide. Now, why azide and cyclooctanes? Why do we take these things? Why are these the best examples of bioorthogonal reactions? Because they react almost with explosion kinetics. They are catalyst free. They are performed easily on cell surface. The cyclooctanes can be modified so that the kinetics further increases. The azides are small, they are stable, they are biocompatible, they are inert, they are non-toxic, and thus they have all the attributes wherein we can use them in biological systems. And also we can take these for labeling proteins, sugars or lipids with fluorescent linkers, for labeling disease or therapeutic targets without any effect to the three-dimensional structure of proteins, sugars or lipids. Now, if we take a normal alkyne which is not cyclic in nature, and then we take an alkyne which is cyclic in nature, you know, this is a stable system as compared to this because this cyclic alkyne is highly strained. So its energy is very high. In this graph, I just want to show you that this is a normal alkyne which has very, very low energy and is highly stable, whereas this cyclic octane, this cyclooctane is a high energy species. When this is a high energy species, because of huge strain associated with it, it is at a higher energy. Now, if we have to make a transition state from this and we have to make a transition state from this, the transition state for both will be the same at this energy. Now, you can easily see that the energy required, that the activation energy required for the reaction which is carried out from the cyclic octane, it is this much of energy. This activation energy is needed, while the activation energy needed for the same reaction with the terminal alkyne, it is this much of activation energy, which is very, very high. Thus, the cyclic octane, what it does, it decreases the reactant stability. Decreases the reactant means increases the energy of the reactant, decreases its stability. Accordingly, the activation energy is very, very low. That required is very, very low. Thus, if we carry out the reaction with this and carry out the reaction with this, because of its huge instability, it will be highly reactive and its activation energy will be low. Thus, it will react very, very fast. It will react with an explosion kinetics. The second thing is that the transition state is stabilized. In one case, in this case, the transition state is like this. In other case, the transition state is over here. You see, over here we have this much of difference of energy between the reactant and the transition state. Over here in the second case, this much is the difference of energy. So we have transition state stability, means the transition state is at a lower energy, activation energy needed is small. So the transition state in the second case is at high energy, the activation energy is more. Now these are some of the cyclic strained cyclooctanes, some of the strained cyclooctanes that have been used to react bioorthogonally with azides and then to give the triazole. Now, bioconjugation generally involves modification of amino acid residues to modify a protein in some way. For example, we have cysteine. Cysteine has a thiol group, SH group, and lysine. Lysine has an extended NH2 second chain, CH2, 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 and then NH2. We can modify this NH2 and we can make it a triazole. Sorry, we can make it an azide. And this azide can then be reacted bioorthogonally with the strained cyclooctines, and they will at once couple with each other with an explosive kinetics. These bioorthogonal reactions are used mostly to attach fluorophores or to immobilize proteins on a surface. Let us take an example. For example, this is a live cell. You have a chemical reporter over here. You have some modified group. Say, for example, this is an amino acid lysine, and lysine has been attached. Some other organelle is also there, or maybe this is a protein or an epitopic part of a protein which contains the same type of functionality. This functionality is reacted with a mannose, which is azidoacetylated at the N, amino mannose, which is azidoacetylated. Azidoacetylated means you can see it is amino mannose, NH2, but it has been acetylated, and then that acetyl at the alpha position has been azidated. So thus this is an azidoacetylated mannose. Now, when this is reacted with this, you will get a this functionality getting connected to the mannose through biotechnological engineering. This can be made possible, and you have then this N3 group, which is N double bond N double bond N, that is an azide group over here. So you have introduced an azide over here, and similar group is over here also, thus and the same group has been introduced over here also. Now, when this is reacted with a strained cyclooctine, a suitable cyclooctine, which is in turn attached to a probe, this cyclooctine automatically within the biological system in vivo, this reacts with this azide as well as this azide, and the probe gets attached to this. The probe gets attached to this over here by forming the triazole ring, which does not need any catalyst, no high temperature, nothing. So whenever they see together this and the azide group, they react and they form the triazole. Now this triazole is very, very strong group. This does not break under normal biological conditions. So when this is stable, that means this probe will remain with the cell. So this probe, that can be a fluorophore or something, this remains over there, and you can track the process of the cell. You can track the process of any modification or whatever effect the cell undergoes. You can track it because you have attached a probe through suitable chemical reactions with this cell at its surface through different suitable chemical approach. Now, diverse biomolecules can be visualized with selective bioorthogonal chemistries. For example, within the cell, you have water, you have thiol groups, you have these aldehyde or acetyl groups or keto groups, you have oxygen, but then you want to do a chemical reaction at a particular target. Thus, you can choose what type of bioorthogonal reaction will be suitable so that this target only reacts with your chemical reporter. Not water, not thiol, not the other groups, because there are so many chemical entities present over there. So when you take the exact biocompatible chemical reporter, the two react with each other, and you will see this type of association happening. So thus you have introduced to your target a chemical reporter which is blue in color through a chemical reaction which is exclusive and selective at the target, not on any other molecule over here. So afterwards, this blue, this is a chemical reporter now. Now it can react with its complementary group to which a probe is attached. For example, we have a complementary group like this semicircle, blue semicircle, and to it there is a probe attached. Now a covalent labeling takes place. Say for example, this is a strained cyclooctane and this chemical reporter is an azide group. Now there will be a chemical reaction between this and this. Similarly, I have shown this circle exactly fits this, which means that there is a chemical reaction, suitable chemical reaction without the use of any catalyst in the biological system, and your probe gets attached to the target, leaving all other things as such without attaching to those things. A similar thing also I have shown in this case. So you have a cell surface, then you have again this N-azido mannose, azidated acetyl mannose at the N position. Now again there is N3 group, as probe is there, and then you have a strained cyclooctane. This strained cyclooctane reacts with the N3 group and you get a triazole. When this triazole is there, you can see, for example, we have the chemical reporter edited cell tracking in vivo. If you take in vivo, for example, this is transplantation of chemical reporter edited cells. We have cells which have been edited and chemical reporter has been introduced on those cells. These cells are transplanted into, for example, liver. Now these these transplanted cells, they contain a chemical reporter N3, 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 azide. Now what you do, you take the probe, the strained cyclooctane ring, I'm sorry. So the strained cyclooctane ring that is in vivo reacting with these N3 groups, and when that is reacting with it, automatically you will see that a probe has been attached to these cells in vivo. You have these cells and then there is a probe, So this probe can be used for studying some of the processes that are happening at these particular cells. That's why this bioorthogonal chemistry is very, very important in attaching a particular probe to a particular target, selected target, and leaving all other things as such. Without bioorthogonal chemistry, that is almost impossible to selectively target a particular thing. Not only this, if you have a group attached to a particular target, for example, we have a cancerous tissue, we attach a chemical reporter to it, and then we give a drug which is a chemotherapeutic drug which has complementary functional group with the chemical reporter. When this drug goes, it does not react with any other tissue, but directly goes to the tissue to which the chemical reporter has been introduced, and it specifically targets that tissue. So you have target specific drug delivery possible through bioorthogonal chemistry also. So that's why I told that this is a technique for disease treatment as well as for disease diagnosis using suitable probes. Now, what bioorthogonal chemistry has been successful in achieving till now? It has been successful in live cell labeling and imaging. It has been successful in drug delivery at effective concentrations and target specific drug delivery, pathogen detection and disease diagnosis. It has been effective in vivo labeling and tracking of biomolecules. It has also been very successful in radioimmunotherapy. Now, these are some of the related papers that we have published earlier in the University of Arizona with some groups. So these also are from US. We have done some chemistry for these bioorthogonal reactions to make different sorts of triazoles under metal and solvent free conditions so that they can be effective within the biological systems. So this is a paper which is in press right now, and it will be published soon, inshallah. So this is from the work that I recently did during my Fulbright. I just returned 2 months back from USA. So these are some of the other papers that other groups in this field have published till now. There are so many, but just few of them I have enlisted over here. Bioorthogonal copper-free click chemistry for labeling and tracking of chondrocytes in vivo. Now, these. Thank you so much. Thank you so much. I think I'm done with it. So.
Thank you, Dr. Abid.
Thank you so much
for this informative presentation.
I'll be happy.
Yes.
I will be happy with any
and
questions.
please.
Dr. Shazia, am I allowed to ask a question?
Yeah, anybody can ask.
Okay. Abid, first of all, thank you a lot for this nice presentation and exposing us to this nice work. I'm actually myself from biology. To be more specific, I work with the proteins and antibodies.
Thank you so much for your
very
kind
much
words. Yeah, you go ahead.
because I saw its scope in labeling the different proteins. Like, I will ask right now a just simple question. After that, I would definitely like to discuss with you in detail sometime in private. You know?
Yeah, definitely.
It's a lot of scope. Yeah, maybe we can then think of something. Right now, my question is simple. When you use it as a labeling, say like a cell surface protein.
Yeah.
Like you said, you use the functional groups like the free amino group, or you use the thiol group of the cysteine and
exactly.
This thing. How you basically manage to, maintain the specificity, because there will be a lot of other proteins on the cell surface. How you maintain that specificity when you want to target just one protein, one particular receptor or ligand or surface something? Do you, did you work with, actually yourself with these cells, labeling of the cells with this?
No. That is the work of protein biotechnologists. They do it, but our work is when they tell us that we have engineered this type of tissue, and then we have introduced this type of group in this particular transplanted mass of cells. Now we want to attach this type of probe with it. Then they give us the probe. We find suitable chemistries to attach that probe.
They give you the purified protein also, basically, most of the time.
No, not at all.
No.
What they tell us that we have engineered this type of cells, and there is a functional group, say for example azide group. They already introduced this. Then they tell us that we want to introduce this type of probe and want to attach it with the chemical reporter that has already been introduced to the cells. So now you tell us what is the by which we can link this type of probe to any molecule which will then react in vivo with the chemical reporter that has been already introduced. So that type of work we do. We think of
excellent. Yeah, relate to the same, like all these probes you use, you showed us these cyclohexanes, cycloazides, and this thing. Do you have any idea like what impact they have on the solubility of the protein?
Yeah, sometimes they immobilize, but that has to be optimized, right? For any particular chemistry, it is not foolproof that you design any particular chemical reaction and then you will think that it will not interact with the protein, and the protein will not change its solubility or its three-dimensional structure. So that has to be optimized. We design a particular chemistry, we give to the biotechnologists, they react it they react with the particular chemical reporter and the protein. Then they themselves have methods by which they can see whether there is change in any particular factor, and that whether that is going to affect their particular the intended use, or it doesn't have any effect. So if they find that the chemistry that a chemist has designed has exactly this all suitable effects, then only they will go with that. But that has to be optimized. Nobody can predict before doing any particular chemistry whether there will be any changes on protein or not, because you know how complex the biological systems are.
Okay, definitely. I would like to get in touch with you regarding this. Huh?
Sure, anytime.
Sure. Okay, Allah Hafiz.
Allah Hafiz.
Participants, if you have some other questions, you can directly ask to Dr. Abid. I don't think we have any questions, Dr. Abid.
Thank you so much.
Thank you. Thank you. You have enlightened us with a newer concept of this bio-orthogonal chemical reactions and transformations. And I hope we can take some clues from such presentations and use them in our own research areas. Thank you, sir.
Sure. You are most welcome.
You,
Thanks
sir.
a lot. Thanks, everybody.
Over to you, Geer, sir.
Yeah, that brings us to the end of this particular session. So we'll meet again at 2 p.m. All of you are requested to take a break, have lunch, and be back at 2.